So I have a Rube Goldberg machine whose whole purpose is to take a selfie of me when the machine is done running. So I wanted to tell you a little bit about the machine itself and how it operates. So the first thing I do is I pump this Nerf gun, and when I pump it, it compresses a spring inside that compresses according to Hooke's law, which states that the force stored in the spring is proportional to the spring constant times the distance compressed. So when I pull the trigger, the spring releases its energy into the dart. So the first thing that happens is the dart goes flying through there. That's the first part of the machine. So then the dart flies into this cup and strikes it, which is attached to this meter stick. So a good portion of the kinetic energy is transferred to the meter stick, but the problem is that since the even though the velocity is fairly high for the dart, its mass is so little that it doesn't have much kinetic energy. But it still does take the ruler, which is suspended, and slightly moves it. So that's the second part, is that the meter stick moves a little bit. When it moves, it strikes the Matchbox car. And this is the third part of the machine, is the Matchbox car rolling. So once it gets struck, it already has some kinetic energy, but it also has some stored potential energy just from the height that it's at. And the potential energy that it is mass times the acceleration due to gravity times the height. So as it goes down this incline, it is basically converting or potential energy into kinetic energy. So it gets down here, and we start the fourth part of the Rube Goldberg machine, which is it strikes the first ball in the Newton's cradle. So it strikes the ball, imparts some velocity, and the ball does the same thing. It also goes lower, and as it goes lower, it converts potential energy into kinetic energy. It strikes the other balls, which stay fairly still, but they do move around some because the car is going so fast when it strikes the ball. But what happens is it transfers a large portion of the energy to the final ball. And this is a pretty highly elastic collision because of the hardness of the balls. Now, nothing on this scale can be perfectly elastic, but in elastic collisions, momentum and kinetic energy are conserved. So this last ball comes up, it strikes this marble, which also is a fairly elastic collision. It doesn't last for long. And some of both of these stages, the energy is lost, and the machine produces sound, but that's a fairly negligible amount of energy. So the ball, yet again, it has kinetic energy starting out, but it also has potential energy from the height, the acceleration due to gravity, and the mass of the marble. So it rolls down the incline, and as it rolls down the incline, the potential energy is becoming kinetic energy. So it rolls down the incline, and this is the fifth part, is it rolling down the incline. And then right here, it changes direction suddenly. And it's a fairly inelastic collision because the cardboard tube that it strikes is fairly flexible. It absorbs much of the energy, and it also changes direction. So I really think that once it starts to drop, it's actually a sixth part of the machine, but you can decide that for yourself. So as it starts to fall down into the tube, a lot of the kinetic energy that it already had before is lost due to it striking that back wall of that tube. But there is quite a bit, relatively speaking, of potential energy that the ball has just from the height differential between the top of the tube and this tube. Now, this tube has several marbles inside to put pressure on this spacebar key. I couldn't get it to activate the spacebar key with just one marble, so I had a lot of weight already in here, and it was just barely on the verge of pushing the spacebar. In fact, that was a lot of the troubles I had, was either the marble would fall in and it wouldn't push the spacebar, or it would push the spacebar. So in this last step, this is pretty much a totally inelastic collision. I mean, the marble bounces a small amount inside of here, but it doesn't bounce off the other marbles, and so very much. So it's considered an inelastic collision. And in inelastic collisions, kinetic energy is not conserved, but momentum is. So this tube pushes down on the spacebar key, which clicks on this, which for some reason won't focus, but it says take photo. And so you move in front and it takes your photo. Now, as anyone who's ever built a Rube Goldberg machine can tell you, there was definitely a lot of trial and error in this. I first was going to try to use my phone to do a selfie. Well, I didn't realize how hard it would be to actually get something to activate the touchscreen. I tried pretty much everything I could think of, and tried for about 3 hours researching on the internet, trying different materials. I tried everything from a glove that had the specialized tip that operate touchscreens, but it wouldn't work when it wasn't on your finger. I tried lunch meat. I tried aluminum foil over a Q-tip, and all these things people were telling me on the internet that these things would work, but it really didn't work without the capacitance that the human body has. And so I ended up deciding to just use the computer, because it's kind of a stationary machine to begin with. And then I also, there's always issues with getting everything tweaked exactly right so that one stage operates another reliably. And it always seems like you'll get that one good run, but then, the person that's operating the camera doesn't get the right angle, or you decided to start before the video started. And then when you do get a good video of it, something happens, like the ball here strikes the end of the ledge instead of actually hitting the other marble. But it was not my first Rube Goldberg machine, but I definitely had fun building it. Thanks.